Welcome, you curious mind, to a new deep dive. Today we're venturing into the fascinating and often surprising territory of prompt engineering in artificial intelligence.
Yeah, it's a big topic right now.
It really is. And, you might be wondering about the depths here, but consider this. We're going to explore it through a pretty unexpected lens, something you actually brought to our attention, the world of computer networking. And believe it or not, the OSI model.
That's right. We looked over the materials you shared on both prompt engineering and the OSI model, and our mission today, I guess, is to understand why prompt engineering is just so critical.
And why it feels so unpredictable sometimes.
Exactly, especially when you're trying to get the best out of these AI systems.
Okay, I like this. Think of it like this. In pool, prompt engineering is kind of like that final black 8-ball shot.
Oh, okay.
It's the action that can, decisively lead to the outcome you want, or it could all just go sideways.
Scratching on the 8-ball? Yeah.
Right. It's crucial, and sometimes the result isn't quite what you thought it would be. Okay, let's unpack this. To really see how this analogy works, we should probably start with a basic understanding of the OSI model's 7 layers. Could you give us a quick rundown?
Sure thing. So the OSI, or Open Systems Interconnection Model, is basically a framework. It helps understand how different networking systems talk to each other.
Right.
It's organized into 7 layers. Layer 1, the physical layer, that's all about the actual cables, the wireless signals, the raw bits flying around.
Actual hardware.
Pretty much. Then layer 2 is the data link layer. That focuses on making a reliable connection between devices that are directly connected, like on the same local network. It handles error checking, that kind of thing.
Okay.
Layer 3, we have the network layer. This is a big one. It's responsible for routing data packets across different networks. Think IP addresses.
Got it. So that's the fundamental plumbing, the pathways for data. What happens next?
Well, layer 4 is the transport layer. This one's key for ensuring data gets delivered reliably from one application all the way to another, end to end. It manages breaking down data, making sure it all arrives, and putting it back together.
Like TCP.
Exactly. TCP is a prime example.
Yeah.
Then layer 5, the session layer, is about managing the actual conversations, the sessions, between applications, setting them up, keeping them going, tearing them down.
Okay.
Layer 6 is the presentation layer. This one deals with data formatting, things like encryption, compression, making sure the data is in a format the application layer can actually use.
Right, translating it almost.
Sort of. And
Okay.
finally, layer 7, the application layer. That's the one the user, interact with directly, your web browser, your email client. That's layer 7.
Okay, so it's a very structured, very protocol-driven system for making sure everything communicates properly.
Very standardized, yeah.
Right, very logical, very neat. But we all know that the real world often throws a wrench in the works, doesn't it?
Yes, it does.
And that brings us to the unofficial, almost legendary Layer 8 of the OSI model. Tell us about that one.
Yes, layer 8. This is where it gets, well, interesting. And maybe a bit messy. Unlike the official 7 layers, layer 8 isn't formal at all.
Right.
It's more of an inside joke, almost, in IT circles. It's often called the human layer or sometimes the political layer.
The human layer, I like that.
It basically acknowledges the huge and often really unpredictable influence that human behavior and, organizational factors have on how well network systems actually work, their security, their success.
So it's basically admitting that even a perfectly designed network can be, well, messed up by us humans.
Pretty much.
Can you give us some examples of these Layer 8 issues? What does that look like in practice?
Oh, absolutely. Classic example. User error. Someone clicks a bad link in a phishing email, compromises their account, or just types the wrong thing somewhere. That's layer 8.
Okay, yeah, I can see that.
Then there's inadequate training. People just don't know how to use the systems right, or they're not aware of basic security stuff. That creates vulnerabilities, social engineering, manipulating people to get sensitive info. That's pure layer 8. And it's not just individuals. Think organizational politics, different departments with conflicting goals,
Oh, yeah.
management making decisions without really understanding the tech, budget cuts impacting security.
Yeah.
All that stuff seriously affects networks. Some even joke about a religious layer, people getting weirdly attached to certain technologies, even if they're not the best fit.
It's funny because it's so true. I think we've all seen projects kind of stumble because of exactly these kinds of human issues. And the sources you shared really drive home the real consequences, right? It's not just a joke.
Not at all. In cybersecurity, a huge percentage of successful attacks trace back to human actions. People falling for phishing, using weak passwords. Those are layer 8 weaknesses being exploited. And it's not just security breaches. Think about IT projects failing because users weren't trained properly and just didn't adopt the new system. Or communication breakdowns within the company. That's wasted money, wasted effort. Layer 8 has very real teeth, even if it's unofficial.
Okay, so we have this neat structured OSI model, layers 1 to 7, and then this informal layer 8 sitting on top, the messy, unpredictable human part. Now let's pivot. Connect this to AI. How does this relate to prompt engineering?
Okay, this is where the analogy, I think, becomes really insightful. Prompt engineering, especially with these large language models, LLMs, it's the whole process of designing and refining the instructions, the prompts you give the AI to get it to do what you want.
Right, the actual words you type in.
Exactly. And here's the crucial bit. It's the final step in interacting with the AI.
Yeah.
The model itself has been built, trained on massive data sets. That's kind of like the underlying infrastructure, your layers 1 through 7 in the network.
Okay.
Prompt engineering is what happens after all that when a human actually tries to use the thing.
Ah, I see the parallel. So prompt engineering, this human-created instruction, it sits on top of the AI model, just like layer 8 kind of conceptually sits above layer 7 in networking.
Precisely.
It's the human interface layer that massively shapes how the AI actually behaves and what kind of output you get.
Exactly right. It's not part of the AI's core design or its training data. It's this external layer of human interaction and guidance. And this brings us right back to that black 8-ball idea.
Yes.
Yeah.
Okay, walk us through that. How is prompt engineering like hitting the 8-ball?
Well, think about it. In pool, sinking the 8-ball is the game-deciding shot, right? Get it right, you win.
Right.
Similarly, a really well-crafted prompt, it can unlock those insightful, accurate, super relevant results you want from the AI. It's the difference between getting some generic fluff versus extracting something genuinely useful and specific to your needs. That's pocketing the 8-ball cleanly.
Okay.
But just like messing up the 8-ball shot means you lose the game scratching, knocking it off the table. A poorly worded prompt, something unclear or maybe biased, that can lead straight to irrelevant, nonsensical, or just plain wrong outputs from the AI.
It's an immediate and decisive impact.
Totally. Sink it or scratch.
That makes a lot of sense.
Yeah.
And the research you shared, it really hammers home just how sensitive these AI models are to the specific prompts they get. It's almost hard to believe some of the numbers.
It is pretty wild, isn't it? The data shows that even tiny changes, different wording, adding a comma, using a slightly different synonym, these seemingly small things can drastically change the AI's output.
Like how much?
Well, one study you sent showed accuracy differences of up to 76% just based on how the prompt was formatted.
76%.
Yeah.
Just from formatting.
Yeah, and even really advanced models like GPT-4, they've seen significant performance drops just from little tweaks in the sentence structure of the prompt.
Wow.
It really highlights how these incredibly powerful models are also incredibly sensitive to exactly how we talk to them. It's like they have their own internal grammar we need to learn.
That huge margin, 76%.
Mm-hmm.
It really underlines the unpredictable nature here. You could mean the same thing, but phrase it slightly differently and get a totally different result.
Exactly. And think about the real-world stakes. Customer service chatbots, for instance. If the prompts they're built to understand aren't well designed, they just won't help people effectively. Leads to frustration, wasted time.
Right. Or content generation tools, code assistance.
Same thing. The quality of the prompt directly impacts how useful and efficient those tools are. Bad prompts mean bad results, means you don't achieve what you set out to do.
And it's not just about getting the right answer in a factual sense, is it? There's also this inherent unpredictability in how LLMs respond, even to prompts that seem really similar.
That's a great point, yeah.
Ugh.
Despite how smart they seem, these models are fundamentally complex statistical machines. Predicting their output with absolute certainty, it's incredibly hard.
Which is where that magic 8-ball idea comes in, maybe.
Kind of, yeah. You ask a question, shake it up, an answer appears. But the reasoning behind the answer is often totally opaque. It's hidden in this vast web of connections and data the model processed. That lack of transparency adds to the uncertainty.
So you can't always know exactly why the AI gave you that specific response to that specific prompt. That must make it really challenging to consistently get what you want.
It does, and that's precisely why human expertise is so crucial in prompt engineering. It's not just a technical skill, understanding the model architecture.
Right.
It also requires intuition, creativity, a really good grasp of the subject matter you're dealing with, and a nuanced feel for language itself.
So it's both an art and a science.
Absolutely.
Yeah.
You need the technical know-how about what the AI can do, but you also need that creative problem-solving ability to figure out how to ask for it in just the right way to get the best response.
It sounds, again, a lot like navigating that layer 8 in networking. You need to understand the users, anticipate their needs, figure out the human element.
Exactly. Just like IT pros need to think about user behavior to keep a network running smoothly, prompt engineers need to think about how humans frame questions and how AI interprets them. This black 8-ball comparison really gets at why prompt engineering is so critical.
It can determine success or failure.
Totally. Regardless of how fancy the underlying AI model is, prompting is the key to tailoring these general-purpose AIs for specific tasks, making them truly useful and accurate for particular needs.
Okay, so if it's that important, why isn't it just formalized? Why don't we have a strict set of rules like protocols and networking?
Yeah, that's a really good question, and the sources touch on a few reasons. First, as we said, there's that big artistic component, creativity, intuition. That stuff is really hard to write down in a rulebook.
Makes sense.
Best practices are emerging, sure, but the best approach often requires tinkering, experimenting, understanding the specific model and the specific task really well.
And the models keep changing, right?
Exactly. AI is evolving so fast, new architectures, new capabilities. Prompt techniques have to adapt constantly. What worked great 6 months ago might not be optimal now or might not work the same way on a different model.
Okay.
And honestly, current research suggests we still have a fairly limited ability to predict exactly how an AI will react to different prompt structures. That makes creating universal foolproof rules pretty challenging right now.
So it's like trying to hit a moving target, basically. The rules keep shifting because the underlying tech keeps advancing.
That's a good way to put it, yeah. And it's interesting seeing all the different ways people try to describe prompt engineering, the different analogies. You shared some of those.
Right, people compare it to writing machine code for AI or teaching a child.
Even just having a conversation or tinkering like a hacker.
Yeah, or giving clear GPS directions, being like a compiler, or even like a knowledgeable friend helping someone cook. It really shows how multifaceted it is trying to get these AIs to cooperate.
All those different metaphors really drive home that prompt engineering acts as this vital, maybe sometimes finicky bridge between what a human intends and what an AI produces.
So wrapping this up, this deep dive, looking at prompt engineering through this OSI model layer 8 lens, it really highlights that just like the human element is critical and unpredictable in networking, our ability to craft good prompts is that black 8-ball shot. It ultimately decides if our interaction with AI is a success or a scratch.
Precisely. It has this decisive impact. It's incredibly sensitive. It demands this mix of technical skill and human intuition. And it's this constantly evolving field that's hard to pin down with rigid rules.
And for you, the listener, getting a handle on this human layer of AI interaction, this art and science blend that is prompt engineering, well, it seems increasingly essential as we all engage more with AI or even just think about where it's heading.
Which leaves us with a final thought, I suppose. As we rely more and more on AI, how will our understanding and mastery of prompt engineering evolve? And what other human factors, beyond just the prompts we write now, might emerge as being critical in how we interact with AI in the future? Something to chew on.